Welcome to Chapter 12, Section 4, Solving Subtraction Equations. Now, just like the substitution property of equality, addition property of equality is the same. We've talked about the fact that to one side you do to the other. Okay, that's what this is talking about. There, you have to be equal. Okay, equality. So if you start off with any type of number, like 3 equals 3, you can add 2 to both sides, and the equality is still the same. You can subtract 1 from both sides, and the equality is still the same. You could even multiply by 2 on both sides, and the equality is still the same. You could divide by 4, and the equality is still the same. You could even raise it to a power, 2 squared. You could square both sides, and the equality is still the same. So please remember, what you do to one side of an equation, you do to the other. And actually, you have to do to the other. So please remember that. So taking a look at this, what we have here is you have a bunch of negatives. Remember, using models right now is okay, but pretty soon in other classes, you're really going to have to just not think of these as models and just work it out. So here you have an x, an unknown, and then 5 negatives. And so we're going to put 5 positives here and add 5 positives here because these cancel out. And now you have a total of 15 positives on the right. Now, what did we added 5 positives to both sides. So, what we're looking at is a reminder from last notes of inverse operations. Inverse operations. Addition undoes subtraction. Subtraction undoes addition. Multiplication undoes division. And of course, then division undoes multiplication. So when we're using models, that's very nice to see the pictures, but you're really going to use inverse operations to isolate the variables. So isolate x. Okay, so let's write these steps down again. Step 1, try to isolate the variable. What that means is you undo all operations. You undo them. You use the inverse operations. So here's the x. We need to undo all the operations. So how do you undo a minus 5? Well, you undo it by adding 5 to both sides. So 10 plus 5 is 15. Your solution is 15. All right, w minus 3. Well, we need to isolate the variable. We need to we need to undo operations. So how do we undo a minus 3? Well, undo a minus with a plus. Undo a minus 3 with a plus 3. And you do it on both sides. So minus 3 plus 3 undo each other. And so w equals 12. And of course, you should always try to check to make sure you did it right. So check. W minus 3 equals 9. Well, we're saying W is 12. 9 equals 9. It works. Addition property of equality can be used to solve an equation by adding the same number to each side of the equation. This is what we're talking about, inverse operations. So, look at this. Solve x minus 5 equals negative 1. So first, write the equation. Undo, we're isolating x. Undoing a minus 5 by adding 5. Negative 1 plus 5 is 4. 4 minus 5 is negative 1. So all of this just by looking at the fact that you are undoing subtraction with addition and then undoing the number. Take a look here. Write out the problem. Isolate the variable. Undo the operation. So undoing a minus with a plus. Adding 8 to both sides. So D is now equal to 3. Almost done. The difference between the record high and low temperature in Oregon is this much. The record low temperature is negative 54. What is the record high? All right. So we're finding a difference. So we're subtracting. It's saying that the difference is 173. So that's why we're equal to 173. And it says that the high temperature minus the low temperature should give you 173. So definition of subtraction. Minus minus means plus 54. To undo an operation, undoing addition, you subtract. So now x is I think 119. Because 173 minus 54. And as you can see when you do the subtraction, yeah, it's definitely 119. So the record high temperature is 119 degrees Fahrenheit. So now we have to use that and set up this story problem here. It's saying the difference between two people's ages is 27. So that means the difference, a subtraction problem, is 27. It says that Julia's age is 6. What is the age of Julia's mother? All right. So obviously Julia's mother is older. So we're gonna give her the variable. Julia's age is 6. And so the difference between the mother's age and the child's age is 27. Well, how do we now solve this problem? We have a variable. Here's an operation, and here's the number. So we follow the same process we've been doing. We isolate the variable, and we undo the operations, plus 6, to both sides. So the mother's age is 33 years. Okay, so from 12.4, make sure you do the CYUs on page 653. And we're doing exercise, you're going to do exercises 1 to 7, all of them. And then, of course, this will be the work we do in class. Good luck.